Hello viewers, welcome back to the MultiMagix channel. Today's talk is about video basics part 2. So in the last week we have discussed about what is a video, what is a frame, what is a pixel, and what are the different compression techniques, and we discussed about the architecture of the FFmpeg, and we also discussed a little bit about IBP frames. So we will just quickly revisit what we discussed about the video compression, and today we'll go a bit in depth about the IBP frames from the code point of view. So on that note, let's start quickly recap what is a video compression. So as I mentioned, so these are the raw frames coming from a particular uh, device or a scene, and we take each block and then example is RGB to YUV, and then we send it to DCT quantization, and then we do one more sampling on the raw frame called temporal. It means it depends upon the predicted previous frame, and then we take the residual image and then we send this to the Huffman coding, and finally we get the compressed data. So to make it very simple, so we are compressing a video and we are storing it in a container, and this container has specific metadata related to audio and video, which audio codec is used, which video codec is used. We are talking in specific video here. So we are sampling the video in terms of spatially and temporally, and then we are following the process DCT and quantization, and we are sending. Okay, so actually we also discussed about the IBP frames. See here, IBP frames is the sequence. So this is the compression sequence. So we have here the actual frame, and this is the B frame, B frame, B frame, and again I frame, B frame. So I didn't mention here which frames is this, but in between iframes there can be P and B both frames. So that depends upon the settings actually. So we are compressing it like this, and during decompression we also need to follow the same order. So we need to ensure that on the display the frame will be appear unless and until the previous P frame or B frame is appears actually. So this is how actually I mean, yeah. So let's uh, in terms of FFmpeg, how to explore these B frames actually. So this is an MP4 file which has an X264 and AAC, and this is an MP4 file, and we are converting this into this format. We are just changing the video codec here from H264 to H265, and the audio streams remains the same, and the video stream, as I mentioned, we are converting this to 264 to 65. So let's quickly recap what happened. So FFmpeg, it reads this file, it separates the stream, audio stream and video stream, and it here we are reading a packet. A packet here is a compressed binary format of audio video. I mean, a packet can be either an audio packet or a video packet. So based upon the index, if it is a audio, if it is a video stream, we'll be sending it to the codec, and this codec will decompress this packet. In other words, from the packet, from the frame. A frame is a raw frame, and this frame again. So here until now we are decoding the raw frames from the compressed file, and again these raw frames are again sent to a different codec, and from here we are again these raw frames are again compressed here in the form of packets, and again these packets form a stream, and these streams are again packed together into a container. So this is how a video is transported from one format to another format. In other words, what happens during decoding a video and what happens during encoding a video. So this is the flow it happens. So now let's actually look into some code here. So where I have one particular specific project. Let me open that for you. Yeah. So here I have a code called extract frames. So here let's quickly wrap through what are all the APIs we are using here. So basically here I am opening I'm selecting input video file of type MP4, and then I'm allocating the memory, and this code I will share definitely. So these are, I will just show it in the format of code snippets. So here first we are opening the file, and then we are finding the stream indexes, whether it has video, audio, or it has both, and from that we'll be getting the video stream index here. Okay. So once we get the video stream index, we will assign the codec parameters. Okay, so from the AV codec context, we'll be extracting the parameters, and then finally we'll be opening the codec. Codec here means the compressed format. So we read the file, we assign the parameters, we open the file, and then so this is the main loop here. It is. So we read. So if you can compare the PPT and these two side by side, you can clearly see here. See here we are reading the frame, read the packet, and then from that packet we extract the frame. So something similar here. So first, so this is the while loop here. So while AV read frame. So this API is used to read all the packets. So here I am reading the packet, and I am printing that packet information here. And while printing the packet, I am telling okay whether it is I packet or B packet or whatever it is. And then I am writing that compressed format into a file. And as I said, once that packet is sent, so now actually we have just got the packet information. So with that packet, we are sending that packet. So once we send that packet, the compressed format is sent here, and then after that we can use this receive frame. Okay, so here we are sending the compressed data. So first we got the one frame or one packet from the one compressed packet, and then we are sending it to AV codec send packet, and here we are receiving the decoded packet, or which is called as frame. So now I'm just reading that frame, whether it is I frame or whether it is P frame or B frame, or these are all the other types of frames supported by the FFmpeg, but primarily our focus is on B frame because it is the one which plays a key role in the compressions. So now you are storing that particular frame info, that raw frame, into a file, so with the help of this helper function called save frame as image. So here you are allocating, and this is how it looks like. You need to scale the context. You need to convert that YUV frame into RGB frame, because to show it in the color format. Okay. So this is the code which extracts frames from a video, raw frames from a video, into RGB format, and also it also writes the compressed packets into a folder. I will share this code in the GitHub and share the links. So I just want to quickly go through the list of ways. The only thing is first you need to open the context and allocate the memories, and then you need to ensure all the parameters are given properly. So the lot of initializations are there, but it is same for all the things. Main thing is this while loop. So you continuously read the packets. After reading, you send the packet. This runs in one thread, and this receive frame receives the packet, and then here it is decoded. So the video codec format I am using here is X264. So I have hard coded which compressor, which encoder should I use. So I think I have mentioned, yeah, let me search for X264. I think it is H264. Yep. Okay. Sorry, I'm not doing any compression here. It's just extracting the actual raw frames, right? So there is no need of any setting it which compressor. This is just decompression. Okay. So here we are actually saving all these things. So let's quickly run this code. So leave this folder. Okay. So I will just remove all these things here once. CMake dot. Okay, I have linked all the FFmpeg dependencies already. So this is the make. So okay, the code is compiling now. Yeah, the linking is also done. It's almost there. So now let's quickly run. So yep, there you go. So now if you start extract frames, okay, I should give the input file name here. So let me give dot forward samples sample underscore x265. Yeah. So these are all the packets I'm getting. These are all the frames. Total this particular I will have 200 frames. So 100 frames. Each frame has a token. Is it whether it is I frame, B frame, P frame, it is written. So it's a compressed packet, whether it is I packet or P packet or B packet. So you can see here I'm printing the packet details here. So the packet is ETS, DTS, size of the packet. You can see here the size of the packet is 58 bytes and this is 200 bytes. So this is the compressed format and this is the decompressed format. This is called as packet, this is called as frame, raw frame, and both this information I am saving it into a file, and let's see how that looks like. So I'm just quickly opening. So where is my project? It is in yeah, it's here. We go to video basics, IBP frames. So these are the compressed packets actually. So if you can see here, all these are in the binary format. It's a compressed one. So this is the actual frame. So these sizes are also very less. You can see here 2.8 kilobytes, and B frame might be much lesser than that. See, it is for just only 48 bytes actually. So that's where you can see. See here the actual frame size is 2.8 KB. Since it is a B frame or P frame, which is like a predicted frame or bi-directional predicted frame. As you know, in the predicted frame is what we depend on the previous frame. Bi-directional frame or P frame depends upon the previous and the future frames. So for that's why the size is very less here. So I mean the data we store is very less, and then and on top of that we are compressing it. So I frames usually have a lot big size and B frames will have less size. So that's how we can tell that which packet is which. And now let's see what's happening in the raw frames. So if you see the raw frames here, so it's all RGB frames. So that we have, I'm just opening it. Yeah. So you can see here I'm storing it. So this I'm just giving it. So it gives a picture of video, but I'm just actually forwarding all the images. Yeah. Okay. So I have extracted all the raw images in the format of RGB to the folder, and I also extracted all the packets into a file, and each packet is associated with IBP frames. Even frames have also IBP frames, but actually that is just a differentiator, but frames are all raw frames actually. Okay, so this is how we extract the frames and recognize the IBP frames and that different things. So now key thing is how from the FFF, I will show you one more code here. Let me go through. I couldn't able to give a separate code here because there are a lot of modules. I will try to separate this module and give. But I do want to focus you here one particular parameter here. Yeah. See, while encoding a video from raw frames or transcoding a video from one format to other format, we have to set up the encoder properties. So encoder properties in FFmpeg, there is this called max B frames. So where you can use this to play with the compression quality. More the value, more the compression, but more the computation time. Less the value, less the compression, but less computation time. Okay. So that way there are some trade-offs which value to choose. So the typical value is between 3 to 7. So let's check. what is the process here? So it is typically the same, just like you transport the audio packets. I mean, in the previous thing, the same thing here. You just need to go, or the encoding starts. So encoding is a reverse process. So first you need to send the frame actually. So you have the raw frame here. So you are sending that raw frame here. Okay. And that raw frame is being received. AV receive packet will receive this input frame in one context, and sorry, AV send frame sends the raw data, and AV receive packet will receive that input frame and generates the output packet, which is the compressed format. And this output packet, we attach stream index and timestamps PTS, DTS, and we rescale it to the YUV format, and then we write it into the container. Okay, so that's what we are doing. So we just, it's opposite of decompression. In compression, first we send the frame, which is the raw frame, and then we receive the packet, which is like the output packet, which is a compressed format. And this, for this compressed packet, we attach timestamps, PTS, DTS, and we rescale it to the color format. So whatever basic things are required. So during this process, the compression, I mean, the B frames parameter plays a key role here. So as you can see here, this parameter plays a key role here. So let me show you the differences here. So I have made some comparisons already. So as we discussed, B frame is called a bi-directional interpreted frame. The number of B frames is a trade-off between efficiency and the complexity. Using too many B frames can increase in the encoding complexity but reduce the visual quality. Using too few frames can result in a lower compression efficiency. So as we discussed, it should not be too high or should be too low. It should be good a reasonable value such that we can. So now let's quickly see here. See here, I have encoded raw from a video from one format to other format. When I'm encoding it to other format, I have given the value of 0. So you can see here there are no B frames here. So it means in this case the compression quality should be very high. So if you go to downloads, we can see here B frames value is 0. So this is of size almost 10 MB. Okay. And the dimensions are still same, but it is 10 MB. So almost very high quality. And now I just played with maximum. Now I put B frames as 1. So it means it will be used, so out of 1252 frames, I frames are 20, P frames or predicted frames are this, and B frames are 534. And these are all other parameters which are thrown by the X264 library, which FFmpeg internally uses this. So here we are using B frames here, but limited number. So let's see what is the size here in this case. Here it is size 8 MB. You can see it is less than the 10 MB, which means it is more compressed format now. And again experimented with frames 3. So here I got no more B frames are there, 781. So now again with this, to compare the value, it should be less than 8 MB. Yes, it is now 6.6 MB. So 10 MB, 8 MB, 6 MB. So as a number of number of B frames between I frames, more the value, more the compression. More the compression, less the size. But when you decode, it will take more computation time. If you are playing a particular video, the amount it takes to compute, a lot of computation will be there in the background. So a bit load on the CPU will be there. So that's the reason you should not go for too high value or too low. Maybe somewhere between 3 to 7 is a good value actually. Yeah. So that way you can play with this B frames from the FFmpeg point of view using the simple APIs like AV codec send frame, receive frame. With those specific things, we can just understand how important the B frames are. So theoretically, all you can remember is B frame is just a bidirectional frame, which depends upon the previous frame and the next frame. Okay. So in the next, also there are a lot of other parameters actually which plays a very key role during the compression techniques. So for example, if you, my bad. Yeah. So for example, if you go to this particular structure here, it's not loading actually. Yeah. Let's see. It's the codec context. Yeah. There are a lot of other parameters which plays very key role in the compression. So we'll discuss more about like CBP, bitrate, other parameters in the next video. Also, we will see how uh, uh, we will also see a bit on debugging tools like H264 parser and what is the basis for this H264 parser, like null packets and the stream packets and the, what are the different packetizing available, like in the file if there is audio file, video file, or what are the headers, what is the format looks like, and in the the streaming world, how the digital technologies are kind of plays important role. Like all these things we will be going through in the next video. Yeah. Until then, take care. Bye bye.